Hello students, this is going to be lesson 6-2, day 2. We are going to be evaluating trig functions off the unit circle. So our learning targets are going to be to understand how to find the value of the 6 trig functions given the coordinates of a point on the terminal side of an angle in standard position. So if you recall, an angle in standard position has its vertex at the origin, its initial side is on the x-axis, and its terminal side could be in any one of the 4 quadrants. And then theta is always the angle that is formed with the x-axis. So when we're finding the sine, the cosine, the tangent, and their reciprocals for that angle, we are going to be making a right triangle. So we'll always be drawing in a perpendicular line to the x-axis, and then noting that this would be our x distance, this would be our y distance, and we're going to call the hypotenuse r, which will make more sense once we talk about the unit circle. R is going to stand for radius. So Pythagorean's theorem is going to be helpful for us as well, and we're going to see it in the form of x squared plus y squared equals r squared. And we're going to use SOHCAHTOA, so we'll write that down as well. And then, of course, know our reciprocal functions. So remember, sine is opposite over hypotenuse. Our cosine is adjacent over hypotenuse. And our tangent is opposite over adjacent. Okay, so we will just do a couple examples. And our first one says the point 5, -12 is not on the unit circle. Find the exact value of the 6 trig functions. We're always going to start by drawing the coordinate plane and plotting that point, just an estimation of that point. So since that point is at 5, -12, that means that it's somewhere down here in quadrant 4. And so again, we just kind of estimate where it is, and we're going to draw the terminal side of the angle there. And then we're always going to be drawing a perpendicular to the x-axis, and we can put our distances on there. So we have 5, we have -12, so we have our x and our y. Theta goes right here. So now in order to find the 6 trig functions, we want to make sure that we first find our hypotenuse, or the r value. So we'll do a quick Pythagorean's theorem. 5 squared plus -12 squared equals r squared. So we simplify that. We get 169 equals r squared. We take the square root of both sides, and we know that r now is 13. All right, time to find these 6 trig functions. So once we do one, we can always just flip it upside down, do the reciprocal for its partner function. So for theta, we'll start with the sine, and sine, of course, is opposite over hypotenuse. So we want to do opposite -12, hypotenuse 13. So our sine of theta is going to be -12 over 13. And then all we have to do is its reciprocal, -13 over 12 for cosecant. Now we'll do cosine. So cosine will be our adjacent over hypotenuse, meaning we're going to have 5 over 13. And we'll do its reciprocal, 13 over 5 for secant. Finally, we have our tangent, and remember our tangent is going to be opposite over adjacent, and so we will do -12 over 5, and for our cotangent, then we will do -5 over 12. So this one was kind of nice because we had integer values for our x, y, and r, and so we will see another example now where we have some radicals that we have to work with. All right. For example 2, if you want, you can pause the video and try to set up the problem yourself, try to set up the diagram, or if not, we can work on it together. Let's start by drawing the coordinate plane again, and this time the point is -1, -2. So think about what quadrant that would be in. Okay. -1, -2 means I need to go left 1 and down 2. So if I go left 1 and down 2, that's going to put me in quadrant 4. And so now I can make my triangle in quadrant 4. And again, draw my perpendicular, put theta right up against the x-axis, as always. -1, -2. And now I'll do my Pythagorean's theorem to get my r again. So -1 squared plus -2 squared equals r squared. So that's 1 plus 4. And that is going to get me my r squared, which is 5, equals r squared. And so I will get r to be the square root of 5. All right, now it is time to do my sine, cosine, and tangent. Notice we're going to have some radicals, so we will be doing some rationalizing of the denominator. Okay, so maybe I'll start with tangent and cotangent because they won't need any rationalizing. So for tangent of theta, I have to do opposite over adjacent, so that's 2. And for cotangent, I have to do the reciprocal. That will be adjacent over opposite, so 1 over 2, or 1/2. So I did those two first because they don't involve any radicals. And now I'm going to work on the sine. And so to do the sine, I have to do opposite over hypotenuse. So that's going to be -2 over the square root of 5. And so I'm going to rationalize root 5 over root 5, which will give me -2 root 5 over 5. And that's going to be my sine. And if I look back at what I wrote in purple first, -2 over root 5, if I use the reciprocal of that, -root 5 over 2, that will be our cosecant. Okay, now for cosine. For cosine, I have to do adjacent over hypotenuse, so that is going to be -1 over the square root of 5. So maybe I flip it first for secant, that's -root 5. But if I rationalize for cosine root 5 over root 5, I will get -root 5 over 5. And now I have all 6 trig functions filled in. All right. If you'd like, again, maybe you can try to pause the video and try example 3 by yourself. Otherwise, this will be the last example that we'll do together. Yeah, again, I'm going to start by drawing my coordinate plane, thinking about what quadrant -1, 1 will be in. So I need to go left 1 and then up 1. So left 1, up 1, that's going to put the point up there. And so there is my hypotenuse. I'll drop in my perpendicular. -1, 1. And theta goes in with the x-axis. So once again, I'm going to do Pythagorean's theorem. So -1 squared plus 1 squared equals r squared. So that's just 1 plus 1 equals r squared. 2 equals r squared. Square root both sides. R equals the root of 2. Maybe you can guess what kind of angle theta is just based on these side values. But notice what quadrant it's in. And so we will be getting some negative values. But these are going to look like your 45, 45, 90 values. You're just going to have some of your trig functions be negative. Okay, let's start with, again, I'm going to do my tangents first because they are going to be easy with no radicals. So tangent, 1 over -1, so that's just -1. When you reciprocal a -1, you still get -1. So tangent and cotangent, notice, are negative. So this is a 45-degree angle, but it's in quadrant 2. That's why it's negative. All right, let's look at sine. So for our sine, we are going to have to do 1 over the square root of 2, opposite over hypotenuse, which means if I flip it, I get root 2 for cosecant before I go in and rationalize it back for sine. Times root 2 over root 2, and I get the square root of 2 over 2. Square root of 2 over 2 is our sine. Now when I do my cosine, notice it's very similar. Adjacent, though, is negative 1 over root 2. So when I reciprocal it for secant, I just get negative root 2. And then, of course, rationalizing will give me the same result as sine, only we have a negative answer. We're going to get negative root 2 over 2. So negative root 2 over 2 is going to be my cosine. And so now we have the 6 trig functions for the angle that is formed in quadrant 2. But again, notice it looks like a 45, 45, 90 set of values. Okay, so the triads are following, so you should work on those. And then this is what we'll kind of start with when we're back in school again. See you soon. Thanks. Bye.